Hi everybody again. Uh, this video is going to be related to the Picoscope. As you see here, that's our Picoscope. That's the digital oscilloscope we're going to use. Well, if you just look the back of the oscilloscope, you will see there's a cable like the printer cable, and this one is connected to the computer. So the signal will be going through the Picoscope and then to the cable to the computer. So we're going to use the screen of the computer to view the signal. And what about here in the front? In the front, you will see you have like, four plugs here. The first and the second A, B. It means this is channel A and this is a channel B. So you got two channel oscilloscope. What does it mean, each channel? It means you can watch two signals at the same time. Each signal will be supplied to A and B channel. And you got external signal input and you got generator. It means, you can generate signal using the computer and this device to produce any signal that you want. In our experiment, we are not going to use the last two. We are going to use AB oscilloscope channels. So let's see, how can we do that? I already set up the function generator as I explained in the last video. I did the setting and the setting square wave, all right, and the frequency about 120 hertz. If I get closer to it, let me move it here. That's 120 hertz, right? And you see the green light here. That's in the square wave, and that is the range, all right? And the amplitude, you don't know the amplitude, you got to measure it. So I just, move it, to clockwise and clockwise till I get the right thing. And the cable is connected, as you see here, and then it's connected. I'm going to have to connect the other end to the Picoscope. So that's the other end of the cable. And you see how plug. Okay, channel A. I'm going to plug it to channel A. So I'll just go there. Where is the long cut there? And then after in, I move it to clockwise direction so you can see the button already is there. See this little notch here? That's security knot. If you pull it out, it's still in. So that's the oscilloscope. Then what you're going to do, you will go now to your screen and you'll find the icon here for the, let me get it here. This is the icon for the Picoscope 6. Double click the left mouse, start to open. Yeah, you hear the click, means, okay, here you go. So we got the screen A, and already that's the signal produced, all right? And of course it's running on the screen. You can go there and you just push this button here, it will make it off, it will stop. So you can look at it, take a measurement. So that's the voltage, it's between minus 0.8 to minus 0.6, like, minus 0.7, I think, to plus 0.7. As you see, it is no DC offset, as explained last time. If you want to see it in more clear, you just go here to the scale. That's the scale of the frequency, 5 millisecond per division. That's controlling this x-axis. Just move this one. That's, the axis, it's millisecond, show you here. So I'll just go ahead and let's see if you are going to decrease it, what happened. All right, so we have to make this one on, you see, okay. Make it 2 meters. All right, it's getting bigger, right? You can see more. So now you go back and make it stop here by off. Now we can see the screen very clear and you can see the measurement. Let me change the function generator by the amplitude button to observe if it's going to affect it or not. So now I have to make it running. And I'll start to change the amplitude. You see, make it the amplitude increase and decrease. Okay. Let us stop here and see what we got. All right, I got from -2 to +2. How I did that? I change, the knob of the amplitude in the function generator, and I can also change the frequency of the same thing. So this is the way you can see everything on the screen. So it's a very nice digital oscilloscope actually, and there are many functions you can do, but I want to show you how you can use it, and then you can go ahead and read the manual if you want to do more function. There are a lot of things you can do. You can find, for example, the root mean square, the average value, everything. You just go there and the measurement. And if you want to add measurement, means you're going to add another channel. That's, we're going to, see, let's just try it. Add measurement. Select the channel to measurement. It's A. Here, ACRMS. That's, it was giving the root mean square. If you want to find the average, you can find the average, the maximum, the minimum, whatever. Here we have the everything, cycle time. So peak to peak, let's choose peak to peak because from -2 to +2, peak to peak would be 4. Say okay. You see here now, you can look in the screen, channel A, name peak to peak, value 4.173 volts. Give me exactly the value peak to peak. It means it's not, we see it +2, -2, but obviously it's not the same. That's, we have some kind of error in when we see it. But this is exact value 4.173 voltage, and the minimum, and that's the minimum value, the maximum value, the average, and it gives you everything about it. If you want to go for the measurement and find anything, you just say add measurement, and this is the root mean square. You can find the root mean square. You can find the average. Let's see the average. Where is our DC average? All right. Okay. And now this is the name peak to peak and the minimum and the average value. So it gives you the all information that you need here. Here you see DC average, it's added DC average 104.6 millivolt. It should be 0 if they are equal. So obviously there's some kind of DC offset, very small, we cannot see it. Nothing is perfect. Well, let me just try to change it a little bit. So I will just make it running, and I will change the DC offset here. And let's stop. And you see the DC average changing. So, it can change by changing the generator, the function generator. So, that's, I don't want to make it a long video. So this is, that we can do. It's very nice. This is a starting, and you can discover more properties in this Picoscope. So thank you for your attention, and you will be ready now for your new experiment.